All right, so we wrapped up statistics pretty much last week. So all of that stuff you're going to use if you are taking college statistics next year. Now what we're going to kind of focus on are some things that I wish we had a little bit more time for during the year. And these things are going to help get you ready for college pre-calc if that's if that's the route that you're taking next year, okay? So what we're going to do today, we're going to do a little bit of review factoring. That way on Thursday, I know this week's a little weird. On Thursday, there was one technique that we did that I know it was a little foggy. So we'll clean that up on Thursday. What I want you to write for the definition of factoring polynomials, I know you guys for the most part know what it is, but I want you to write this down. You are breaking up a polynomial into simpler terms. Those simpler terms are the factors. Such that when the terms or the factors are multiplied, and they're all multiplied together, they equal the original. So that's a nice way that you can check yourself. If you're ever not sure whether you factored correctly, you can always just multiply them back and see if you got your original polynomial. So the first thing that you are always going to look for is a GCF. I'm not giving you guys steps to how to do each one. You should know how to do these already. You did GCF back in 8th grade. You're always going to look for a GCF first. Always look for a GCF first. Okay? And then from there, we really didn't do GCF. You guys kind of know how to do that already. There were 4 different factoring methods that we did. Well, 5 if you include the one that we're going to do next week. In a few days, rather. So if you have 2 terms, if it's a binomial, there were 2 different factoring methods. One of them was the difference of 2 squares. Notice it's just the difference of 2 squares. And the other one is the sum or difference, put a slash, sum or difference of 2 cubes. So if you have 2 perfect squares with subtraction in the middle, then you can use that method. If you have 2 perfect cubes, then you can use the sum and difference of 2 cubes method. It doesn't matter whether it's a plus sign or a minus sign in the middle for cubes, okay? However, if you don't have 2 terms, if you have 3 terms, you will use master product. If you have 4 or more terms with an even number, 4 or more, you will use the grouping method. Okay? And you always want to check each factor to see if you can keep factoring. So for example, if you do grouping and your grouping leads into the difference of 2 squares. Okay? You always want to check to make sure that you cannot factor any further. That would be called factoring completely. Okay? So in these examples, number 1, your first example, the directions say to factor completely. So if I can do anything further, I have to do it. So my first step, I always look for a GCF. So between 14 and 35, they both are divisible by 7. And between x to the 4th and x, you can take out an x. So the way you take out a GCF is then you divide each term by the GCF to get the remaining factor. Okay, so 14x to the 4th divided by 7x. 14 divided by 7 is 2. X to the 4th divided by x is x to the 3rd. Then you have negative 35 divided by 7 is negative 5. X divided by x cancels. So now I check to see, can I do anything? I have 2 factors. I have 7x and 2x to the 3rd minus 5. Can I do anything further with 7x? The answer is no. Can I do anything further with 2x to the 3rd minus 5? I cannot, so that's it. Okay, first one is really just GCF. That's an Algebra 1 question. That should not be an issue. Number 2, 18x to the 6th minus 50y squared. So first I'd look for a GCF. 18 and 50 are both divisible by 2. They don't have any variables in common, so the only thing is a 2. When I take out 2, I am left with 9x to the 6th minus 25y squared. Both of the coefficients of each part are perfect squares, right? 9 and 25 are both perfect squares. X to the 6th and y to the 2nd are both perfect squares as well, because both of the exponents are divisible by 2. And then it's a minus in the middle. So you can keep going by using the difference of two squares method. So this 2 has to be brought down. And then the difference of two squares, you set up two binomials. The square root of 9x to the 6th is 3x to the 3rd. That's going to go in the first spot of each parenthesis. Then you would do the square root of 25y squared. The square root of 25 is 5. Square root of y squared is y. So 5y goes in each. Then you have 1 plus, 1 minus. Cannot do anything further, so that's going to be my final answer. Number 3, a to the 6th minus 64, b to the 6th. There is not a GCF here. Even though the exponents are both 6's, that does not matter because your terms are different, your variables are different. One's an a, one's a b. You can't pull out anything. So for this, you are going to look and see 1 and 60. You actually could do two methods here. 1 and 64 are both perfect squares, but more importantly, they're both perfect cubes, right? 1, the cube root of 1 is 1. The cube root of 64 is 4. So you're going to look to do perfect cubes over perfect squares. So to do that, you take the cube root of each one. Doesn't matter if it's a plus or a minus in the middle. This one just happens to be a minus. You set up a binomial and then a trinomial, so leave some space, okay? So here, if you remember, this was your, back when I first taught it, we wrote down what a is, what b is, and then you had a squared, ab, and b squared. And then for the signs, you used SOAP. Same, opposite, always positive. So a is the cube root of the first term. The cube root of 1a to the 6th is going to be 1, which you don't have to write the 1. A to the 2nd, you would do 6 divided by 3 is 2. B is the cube root of the second piece. So the cube root of 64 is 4. The cube root of b to the 6th is b squared. So that goes in the first set of parentheses, so you can put that here if you want. A squared, 4b squared. Okay, now the second part of your parentheses will be a squared, ab, b squared, in that order specifically. So if a is, oh, that's a little confusing. If a is a squared, then a squared squared is a to the 4th. That comes here. A times b, we have a squared times 4b squared is 4a squared b squared. And then b squared would be 4b squared squared. So you square 4 and you get 16, and you square b squared and you get b to the 4th. So I didn't even realize about the variables, so I hope that this doesn't get too confusing. And then for the signs, right, the pieces that are in the middle, you have same. So this started with a minus, right? So same, opposite, always positive. If you look at this, though, your binomial out front, a squared minus 4b squared, you can factor that further using the difference of two squares. So the square root of a squared is a. The square root of 4b squared is 2b. one gets a plus, one gets a minus, and then this thing, you're never going to be able to do anything with the trinomial. So now you have a to the fourth plus 4a squared b squared plus 16b to the fourth. Number 4, we have 8x cubed plus 54x squared minus 14x. So they're all divisible by 2 and by x. So that is your GCF. When I take that out, I am left with 4x squared plus 27x minus 7. So now I have a trinomial that I'm going to try to do master product on. So I multiply the first term by the last term. That gives me negative 28x squared. So I have to find two numbers that multiply to be negative 28x squared, but add to be a positive 27x. Those two numbers would be a positive 28x and a negative 1x, which you don't have to put the 1 if you don't want to. So now I'm going to replace this middle term with those two terms. And the whole purpose to doing this is so that you have 4 or more terms and you can do factor by grouping. On the left side, your GCF is 4x. You are left with x plus 7. On the right side, your GCF is negative 1. You're always going to match whatever this first sign is. So because this is negative, you take out a negative. You're left with x plus 7. The parentheses have to match. Then it comes out. So you have x plus 7 times 4x minus 1 with your initial GCF of 2x. You cannot factor any of these three terms any further. Okay, this is it. That's your answer. Number 5. Number 5 is also three terms, but this is a multivariable factoring. So it is a little bit more confusing. So first of all, 14, 3, and negative 5. No GCF. Your variables, there's not something that you can take from all of them. So number 5 does not have a GCF. So you're going to try right away to go right into master product. So if you multiply 14p to the 10th times negative 5r to the 6th, you get negative 70p to the 10th r to the 6th. So you have to see, are there two numbers that multiply to be negative 70p to the 10th r to the 6th, but can add to be positive 3p to the 5th r to the 3rd? Now this is going to work out because, well, for the numbers are a little bit easier. So multiply to be negative 70, add to be a positive 3. That would be a negative 10. Nope, sorry, that'd be a positive 10. Positive 10 and negative 7. Now for your variables, remember, whenever you're combining like terms, they stay the same. So if you want to add to get a p to the 5th r to the 3rd, you have to add a p to the 5th r to the 3rd. So this is positive 10 p to the 5th r to the 3rd, negative 7 p to the 5th r to the 3rd. And now if you were to multiply these, when you multiply terms, you add the exponents. So when you would multiply p to the 5th times p to the 5th, you get this p to the 10th. When you do r to the 3rd times r to the 3rd, you get that r to the 6th. Okay? And then everything else stays the same. It's just amped up a little bit because of the multiple variable thing. So we're going to rewrite the original except without the middle term. We're going to rewrite with our two new factors. And again, this sets you up to do factor by grouping. It doesn't matter if you write negative 7p to the 5th r to the 3rd first before the 10. It doesn't matter. You're going to end up with the correct answer as long as you do that correctly, as long as you're taking the GCFs out correctly. So 14 and 10 both have a 2 in common. P to the 10th and p to the 5th r to the 3rd have a p to the 5th in common. When you divide, you get 7p to the 5th plus 5r to the 3rd. Now remember, whatever you get over here in the parentheses, you should get on the right side as well. So over on the right side, you would take out a -1, so negative or minus. You don't have to write the 1, you can if you want. P to the 5th and no P, so you can't take a P out. R to the 3rd and R to the 6th, you would take out the R to the 3rd. When you divide that out, you get 7P to the 5th plus 5R to the 3rd. And your parentheses match, so that comes out. You're left with 2P to the 5th minus R to the 3rd. Okay? Cannot be factored any further if you look at each of the terms there, each of the factors. And then last one, number 6, we have factor by grouping. There's no, start off right away, GCF. There is none, so you split it down the middle because there's 4 terms. On the left side, you would take out x squared. You're left with 4x plus 7. Right, this is a nice easy one. On the right side, there's no GCF, but you have to take something out. So you take out a plus 1. You don't have to write the 1. Here I suggest you do because there's nothing else there. Otherwise, you might just write x squared. You're left with 4x plus 7. 4x plus 7 comes out. You're left with x squared plus 1. Now, this x squared plus 1 can sometimes get you because sometimes people will do the difference of 2 squares on this. But remember, difference of 2 squares has to be subtraction. That's the difference part of the difference of 2 squares. Okay? So your homework tomorrow will be a worksheet based on some factoring stuff. Let me know if you have any questions. Have a good day.